The severe weather system that produced significant wind damage and a couple of tornadoes across the Midwest is now moving towards the northeast. So currently the remnant mesoscale convective system, which is basically an organized system of thunderstorms, is currently decaying over western and central Pennsylvania, moving into adjacent parts of New York. And there are still some cloud debris from these systems, as seen here in Berners Township, New Jersey. The cloud cover is mainly scattered. It's not too dense, and dew points are around the lower 70s and temperatures are upper 70s, lower 80s currently. Temperatures are forecast to get into the 90s and dew points will stay around the same. And clearly today there's a slight risk of severe weather that has been issued by the Storm Prediction Center. The main threat here is damaging winds. So what's going to happen is this system is going to move from the west to the east, mainly, with the front oriented mainly southwest to northeast. So currently the view you're seeing is towards the southeast, and there is still some convective debris towards the south, but as you can see there is clearing in spots, which is going to help and fuel the instability. So the main factor here today is the instability. The winds will be throughout the profile. The winds are going to be around 30 to 40 knots, especially once you get above 3 kilometers AGL. And it's going to be unidirectional flow out of the west-southwest or west. So what this is going to do is, because this flow is oriented nearly parallel to the boundary, this is going to help fuel the threat for damaging winds with bow echoes, because bow echoes will be fueled by this unidirectional wind profile with similar winds aloft at all heights. So what's going to happen today is after 2 o'clock, storms will begin to fire across the northeast in central Pennsylvania through New York, and the surface low may begin to consolidate around southern New England as the day moves forward. These storms will have a storm motion generally eastward, while there may be some deviations expected, especially across the southern New England area. Here from New Jersey south, the main threat is going to be just damaging winds, because the wind profile will not be as favorable. There will not be as much curvature at the surface. The winds will be more out of the west than out of the south. Towards New England, where the surface low will consolidate, there may be more favorable shear, and there may be more favorable SRH, which is storm relative helicity, to measure how much rotation the storm can acquire. Towards the surface low, this will be more favorable, which provides the threat of a brief tornado with any discrete storms that may potentially form, or any rotating structures within the line of thunderstorms that is expected to move across the area. So across southern New Jersey and northern New Jersey, there may be a line of thunderstorms that form, or there may be a cluster of thunderstorms that form, and this will start moving into the area around 4 or 5 p.m. These storms will have a threat of strong damaging winds with this unidirectional wind profile, and strong winds located just above the surface, around 2 or 3 kilometers above sea level. So clearly the idea here is mainly damaging winds, but there may also be small hail involved in some storms, and there could be potential brief rotations with local wind shear enhancements. So instability wise, there's going to be no shortage of heating or moisture today. However, lapse rates throughout the profile are not going to be the best. Lapse rates are around 5 Celsius per kilometer in the 3 to 6 kilometer layer, which is not very good. This is going to reduce the temperature difference between the air aloft and the air at the surface, the warm air at the surface, the cold air aloft. This is going to reduce the amount of instability we can have. So today, if we do not get as much instability, today could be a bust, just like it was on Thursday, July 27th, where the instability was not the issue, but unfavorable timing was the issue. Today, instability could be the issue if enough instability does not develop. It's forecast to be around above 1,000 joules per kilogram of ML CAPE and around 2,000 joules per kilogram of surface-based CAPE. If more than this arrives, then there could be a higher severe threat, and if less than this arrives, the severe threat could diminish. Across from Cape Cod through southern West Virginia, the main threat, as you can see here, is winds. Hail is a secondary threat, and the tornado potentially exists mainly in southern New England, extending back towards southern New York, and extreme northeastern and northern NJ and Pennsylvania. So if we look right now at the temperatures across the area, well, let's look at the dew points first. There's been clear moisture advection from the south. Dew points have increased quite a bit over the past 24 hours. And if we look at what the actual dew points are, we are mainly talking low 70s to mid 70s dew points. And we can see this front, where the front is set up really. North of this front, we have dry air. So if we look at the temperature change, there has been a general warming trend too. It's quite warm for the morning, even though yesterday was quite a hot day. And currently temperatures are in the low to mid 80s, except for 90s and in Virginia. And this is as of around 11:15 a.m. Eastern. And if we look at the surface analysis, we can see, as we saw with that dew point map, we can see the front draped across southern New England. Northern New England, not really southern. We can see the warm front's already moving off the coast. There's a cold front draped all the way from around Buffalo, New York, down towards coastal New Hampshire. And if we look at how this has progressed, yeah, this is generally progressing southwards. So yes, so basically north of that cold front, the severe threat should be much lower unless that cold front retreats, which is not as likely. We can see there's many areas of low pressure, but one area of low pressure, as we'll see later in the models, should consolidate anywhere in between around Albany towards Boston. So if we look right now at the satellite, the old MCV, MCS from yesterday across the Midwest is decaying. It is basically all gone now. It's just really the upper level debris clouds that we see. There are some fields of cumulus across New Jersey, Pennsylvania, southern New York. There is some prefrontal convection ongoing in this area of New York. What is ignoring all of that debris, we have clear skies out here, and we have clear skies in southern Jersey, just some upper level cirrus around here. So that shouldn't really be too much of a hindrance to daytime heating. And if we look at the radar, we can see clearly that the MCS is decayed. However, here we can see the front over here. We can see some type of rotation, low pressure over here. We can see the front is draped around here. And if we look at the sounding from today morning at New York City, well, Long Island, not really New York City, but we can see clearly here that the lapse rates are not really optimal. Lapse rates throughout the profile around 5.5 Celsius per kilometer, which is really not what you would like to see if you want instability to develop. For severe weather, you'd rather have more like 6, 7, 8 throughout the profile. But that's really doesn't really happen very often in the east. The low level lapse rates, however, the surface to 3 kilometer lapse rates should increase as daytime heating occurs. The sounding was from 8 a.m., so temperatures have increased across the area. And wind-wise, we can see it's pretty much unidirectional out of the west, very slightly out of the west-southwest, but mainly out of the west. And we can see that in the mean wind vector here, the wind is coming out of the basically west, very slightly south, but basically west. And the winds are around 30 knots as soon as you get above 3 kilometers. And this should increase as the main low pressure approaches. The wind should increase. And the main component today for any potential rotation that occurs is A, how backed these surface winds are, how close we can get from the south, and B, how strong they get in the surface to 1 kilometer layer. All right, so let's look at the NAM 3 kilometer model real quick and its depiction. This is the 12 Xeron. We can see what is the time right now. So around 15Z. It is somewhat on track. We can see that convection from here, the slight rotation, the prefrontal convection over here, the decayed MCS, the convection across upstate New York. And what is going to happen is that we can see that more of a surface low starts to consolidate along with the system. And then what is going to happen as time progresses is that there's going to be lines of thunderstorms that form from clusters potentially. So we can see actually this model is being quite interesting. It's imposing some prefrontal convection, potentially discrete or clusters in southern New England. And I'm not really sure if this will play out because that's going to be dependent on whether the cold front retreats. Here, I think in this example, the cold front has definitely retreated from southern New Hampshire to more of like northern New Hampshire. And we can see there's lines thunderstorm forming across upstate New York. There's another line consolidating across New England. And we can see here, we can see across the mid-Atlantic states, we can see scattered thunderstorms all across Virginia, West Virginia. And over here, what's interesting is that across New Jersey and the Delmarva, it has this actually strong line, Boeing line of thunderstorms. This is what we have to watch out for today. These kind of thunderstorms are the ones that can really produce damage. So if one of these does consolidate, it could potentially bring some higher severe weather threat. And one note that I'd like to put, this isn't too much of a scientific type quote, but the idea is that yesterday the system actually outperformed across the Midwest. It wasn't expected to be as damaging as it was, but there were very high winds associated with that. And it became clear that this would happen around 4 o'clock that exact day. So in my experience so far, systems that outperform across the Midwest, moving into the Northeast, generally they do also outperform in the Northeast. This is obviously not always true, but if we do not get that failure mode with the instability that I was talking about, then there could definitely be a significant damaging wind threat across parts of the Northeast where these Boeing segments could consolidate. And the environment is favorable for them. We just need the instability. So if we look at the HRRR model, the 14Z run, this is at 18Z around 2 p.m. Eastern time. We can see scattered convection is starting to reinitiate over west central Pennsylvania, and we can see convection starting to form along the front in upstate New York. And most of the high resolution models are kind of agreeing with this setup. And as we move into, let's say, around 4 p.m., what is going to happen is that this convection is going to start moving forward. Convection is going to start firing further south. And yeah, still they should be agreeing with this, waiting for this to load up. Not loading up right now. Yeah, here we go. Now it's loading. So there are still some timing differences. As you can see, the NSSL high-res window is actually quite further ahead with this, and it's developing more storms across eastern Pennsylvania and not as many out here. And also another thing, maybe also with the potential prefrontal discrete convection. The HRRR doesn't have it very strong out here, but if you look across in this area with the NAM 3 kilometers, there's more out here. So what this could mean is that even small discrepancies could change how this event plays out. And we are going to have to watch, especially radar trends. I'll keep you guys updated. Maybe later I'll release a video about a recap of this event. And we can see clearly, look at this. There's a Boeing segment out in southern New Jersey in this high-res window ARW model. HRRR is having more of a cluster type system, and it's having them further west. FV3 has some clusters, northern Jersey, moving through southern New England and upstate New York. Boeing segments potentially. It's being a bit slow. NSSL has another Boeing segment out here, southern New Jersey. Storms developing. Now let's move towards 6 p.m. 6 p.m. Now the HRRR is providing a strong line of storms in southern New England, moving into southern New England, and we have our surface low consolidating here. So this surface low will be important because what's going to happen is that this surface low is going to provide enhancement for lower level wind shear. This is why this Storm Prediction Center has that higher risk for tornado over here. Well, not higher risk. That's where the risk for tornadoes is. So potentially there's a 2% risk, but there could be a potential maybe 1 or 2 tornadoes. So if we compare this to the NAM 3 kilometer, this isn't as bullish with the line of storms in southern New England, but it's because it has the main surface low more towards Albany. So what this could potentially mean is that the actual main area for severe weather could slightly change, but really we have a solid idea of when this severe weather should move off the coast. So it should be out of New Jersey by maybe around 9. New Jersey, Pennsylvania, southern New York, the storm should be out by around 9. However, storms may be continuing across southern New England, even into the overnight hours, and they will probably be clear by, I would say, maybe 11 or 12 a.m. The rain should be over by probably 11 or 12 a.m. Yeah, so that's 11 or 12 p.m. 11 or 12 a.m., 11 p.m. So yeah, we can see 11 p.m. Storms are basically moving out now. It's gone. So the severe threat should be done by then. So let's look at some soundings in southern New England. So this is the NAM 3-kilometer model, and this model tends to like to go overboard a lot on a lot of things. Like you can see here, it's pushing 3,200 joules per kilogram of surface cape. That should not happen. It should stay within the 2,000 range. And yeah, so this is still just providing an example of what I really want to illustrate. So this is at Bradley International Airport, Hartford, Connecticut. So look at this photograph. Photograph is basically a plot of these winds and in basically a different kind of format, showing both wind speed and direction. So we can see this curvature in the photograph that shows that the winds are curving. You can see at the surface they're out of the southeast, which is actually very back. Which if it becomes that back, there could be a higher chance. Moving out to the southwest and then west as you move up. So in this case, the storm relative velocity, which is basically the area between the supercell motion and the height of the wind and the surface wind, this area basically is the 0 to 1 kilometer SRH, which is 185 meters squared per second squared. And this would drive some higher potential for rotation, especially paired with higher winds just above the surface, 23 knots of surface to 1 kilometer wind shear. This could provide some rotation within those potential lines of thunderstorms. But if we look at an HRRR depiction of the same time at the same place, we can see that the curvature is not as much. This is more likely. The curvature is not as much, more of a flat spike. However, there's still enough SRAs to provide some small rotation. And we can see here the instability is around 2,000 in the surface to surface base parcel. So let's look here at 6 p.m. Let's look at New Jersey, say Somerset Airport around. Let's look at what the profile is looking like. So the HRRR model is the high resolution model and its rapid update. Generally, it's more reliable, but it can have some biases of its own, like especially a moisture bias. It generally is on the lower side with moisture, while the NAM 3 kilometers on the higher side. So if we look at around the 3-kilometer layer and above, we have strong 40-knot winds. This is what you would want for bow echoes. However, in the lower levels, you have only 13 knots of surface to 1 kilometer shear, which is not as favorable, along with the instability. The instability is very low in this scenario. So this much instability were to materialize, the severe threat will be lower. However, more instability is to arrive, and the severe threat will definitely be higher. So if we compare this to the NAM 3 kilometer, which the HRRR just had a cluster of storms. Now we look at the NAM 3 kilometer, which has that line of storms, that Boeing system. The winds are slightly more backed. It has around the same amount of shear, but it's backed. Remember, I told you the change in direction of winds. That provides a more favorable environment for those bow echoes, and there's also slightly more instability in this case. So that would provide a higher amount of severe threat. So the bottom line today that I would say is severe threat is expected from the Boston area down through DC. There's threat of severe damaging winds even down towards southern West Virginia. In this southern area, the main threat is going to be just damaging winds from clusters of storms. In this northern part of that area, there could be potential Boeing segments. And into southern New England, the main threat will also be damaging winds from potential just a long line of storms or potential Boeing segments within those. But some small spin-ups within those lines, some small rotations caused by the enhancements by the surface low could also potentially provide a brief tornado. Hail will be possible in the stronger storms. Please stay safe today, and thank you for listening.